Hey everybody, I wanted to add this addendum to the SPSS assignment instructions because of a really great question that was raised by one of your classmates. And your class deserves some real kudos because nobody has pointed this out before, and I made the mistake of not catching something in our data that we actually need to handle to make sure that the results we're getting are accurate. So in the in-class portion of the assignment, one of the things I asked you to do was to tell me the descriptive information for age. And so I'll use that as an example, but this same example would hold true for the height and weight variables that you're asked about in the take-home portion. So what I want you to do is, if you look at the screen here, you can see that for age, the numbers for age mostly look fairly normal. Somebody's 62 years old, they're 69 years old. This one's pretty odd, 85 plus years old. And if we come over here to variable view at the bottom of the screen, what you see with age is that they actually have some values entered, so that somebody who's entered as a 0 means they're under 1 year of age, and somebody who's entered as an 85 is 85 plus years of age. So that's actually not a really great decision in terms of how to code your data, because now everybody who's, people who are 85, 86, 87, they all are scored the same way as an 85. So the mean's going to come out artificially low with those people included. Now, there's nothing we can do about that because that's the data that we have, so we're a little bit stymied in that regard. But let me show you what that does to the data so you can get a sense of why this is important. If I go to descriptive statistics and go to frequencies, oops, I don't know why that went on the other screen. Go to frequencies. You guys can do it with height and weight. Let me just do it with age first. And I'll go ahead and under statistics, I'm going to ask it for the mean so you can get a sense of what happens here. I'll hit continue. I'm going to hit paste because that's what I ask you guys always to do, and then I'm going to run this. So what you see up here is just some summary data, and it tells us that we have 5,000 valid pieces of information and 0 missing data, and the average age is 49.38. When you look over here in this frequency chart, you see that you have 48 people who are 18 years old, 48 people who are 19 years old, and so on. But what of course is strange is that when you get down here in the 85 plus years group, there's 172 people who are that old. So we don't know, clearly they're not all 85 on the nose, but it is impacting our descriptor so that our average age is not actually super accurate. Okay, now that's not the exact problem. There's not a solution for that. That's the way the people coded it, and there's nothing we can do about it at this point in time except to be aware of the problem. But let me show you what happens if you do frequencies, and I'll take off I'll leave the mean on. That's okay, because you have to do mean and standard deviation anyway, so I'm not doing your work for you. But if I come down here and find where I have, let me just do height, okay? And I'm going to do the same thing I just did. I've got the mean clicked, so I'm going to have the mean. Let me paste this. So I'm going to do the exact same thing I just did, but I'm going to do it for height. When I do it for height, again, it says that I've got 5,000 valid cases and 0 missing, and it gives me this average height. But this one, look at this data here. Here's heights that make sense, but for 306 people, the height wasn't available. 5 people refused to give that information. 31 people it wasn't ascertained, and 16 I don't know. All of those people, if you go back to the data file, were coded as, let me go to, I'll leave it in variable view. If I look at height, these people have codes that mean they were not available, refused, not ascertained, or don't know, but because they're not listed in this column next to it that says missing values, those values of 96, 97, 98, 99 are actually included as measures of height, which we don't want them to be, right? So what we need to do is we need to go to this missing values column, and we need to tell it that we've got some missing values. And those missing values, actually, it only gives me 3 places, so let me do a range instead, and I'm going to tell it that the missing values go from 96 to 99. Right, so 96 to 99 are missing values. That matches with what I used for my missing values over here. I'm going to say OK. Now let's see what happens. The frequency chart will look the same, but you'll see something different. Actually, I don't have to go there again, right? The beauty of having the syntax pasted is I can go here and just run it again. So I run it again now, see how this has changed. Now there are 4,642 valid cases, 358 missing cases, and look what happened to the mean. It's 66.5 instead of 68.63. So we've taken out those invalid cases of 96 through 99. Now, if you've already done your homework and turned it in with those numbers included, no big deal. I'll accept the answer as it is, but I just wanted you to know this because it's a great question and an important one, and one that we would really need to address for any of these where we've got missing values and then they're not coded over here as missing values. All right? So thanks, everybody. Hope you're doing well. I look forward to talking to you next week in the review session. Bye.